We are given a reaction equation and are asked to deduce whether the reaction is spontaneous or not. We are told solid silver metal is placed in a lead 2 nitrate solution, and this is the reaction equation which we have to figure out is occurring spontaneously or not. To determine if the reaction is spontaneous or not, we need to know the cell potential, E cell. Cell potential, also called cell voltage, is the potential difference between two half cells and is measured in volts. Now, we do not have two half cells here, but we can still use the cell potential to determine the spontaneity of a reaction if we know the oxidation and reduction half equations. A positive cell potential indicates a spontaneous reaction, and a negative value a non-spontaneous reaction. A non-spontaneous reaction would require the input of external energy to drive the reaction. We can find the equation for cell potential in the data sheets. It is E cell is equal to the electrode potential of the cathode minus the electrode potential of the anode. Or we can say the electrode potential for the reduction process minus the electrode potential of the oxidation process. Since we have no cathode or anode here, let's remove the top equation. We need to figure out the oxidation half reaction and the reduction half reaction. Then we must look up their electrode potentials on the table of electrode potentials. We start by filling in oxidation numbers, and silver has a value of 0 since it is an element. The same goes for lead. The oxidation number of monatomic ions is the same as their charge. So therefore 2 plus ions have a 2 plus oxidation number and 1 plus ions a plus 1 oxidation number. Silver's oxidation state is changing from 0 to plus 1. Silver is losing electrons and so it is oxidized. We can find this oxidation half reaction on the table of electrode potentials. Now this equation written from left to right is a reduction, but remember we are looking at the reverse half reaction, which is an oxidation. The electrode potential value for the forward reaction, which is written as a reduction, is positive 0.80 volts. This value will be converted to a negative value when we substitute it into the cell potential equation, since we are looking at the reverse half reaction, the oxidation half reaction. Then lead 2 plus ions each gain 2 electrons and are reduced to lead metal. This is the half equation which we must look up on the table of electrode potentials. The equation as written from left to right is a reduction, and its associated electrode potential is negative 0.13 volts. We can put these values into the cell potential equation, and we get negative 0.93 volts. The negative sign tells us that the reaction given to us is non-spontaneous. To get the reaction to occur, external energy would need to be used to drive the reaction.